BFD crypto, and do return presentations on things like stability and also the reference return path. So status-wise, we're continuing to keep things up to date in the wiki, so this is the place to see what the chairs actually perceive the status of various documents that are presented inside of BFD and outside. So please feel free to look at that, and if you see something that's wrong in the wiki, please feel free to edit it. Since last IETF, we've had 2 RFCs published. One of them is actually within BFD, which is the BFD intervals document. Thank you for doing that work. The other one is that the CARP document, after CARP closed down for BFD requirements, finally hit RFC with a little bit of help from the BFD people pushing it through some IETF last call issues. So that one is also published. Now in terms of where everything else is, the BFD auth documents are still stalled out in terms of stronger auth, although hopefully the talk today will give us some incentive to maybe move that forward. The BFD multi-point document, Santosh DK has actually done a nice job for us in terms of splitting that very large document up into procedures that everybody is implementing in their multi-point stuff, so that's great. And they also has got a new document which we should put through the adoption process after this IETF, which covers the active tail procedures that have been refactored out of that document. Seamless BFD is progressing a little bit slowly right now, but I suspect that's because some of the key players are doing things like moving across the planet. Use case document did finish working with the group last call, and we have a couple of last minute comments integrated in that, and once that's been completed, we will verify with the people that had said yes to the last call and send that off to the ISG. Alert discriminator document's been recently refreshed, and we'll give a presentation on that today. Base and IP has not gone through any recent revisions. We'll hopefully be seeing updates on that sometime soon. The 5884 clarification document was pretty straightforward. It's probably ready for last call. We were just running it through a little bit of time to allow the working group to have a chance to look at that. My suspicion is we probably want to have the MTLS working group take a look at that as part of the last call procedure as well. The Yang team has been kicking butt and working a lot of long hours to actually produce their first Yang module for BFD that went out just a couple of days before the cutoff. It's structurally in modestly good shape, especially for a bunch of people who are sort of doing Yang 101, so that's a great thing, and they could use your help in 2 respects. The first one being obviously please read it and provide general feedback, and the second one is if you have some sort of operational background, please take a look at this for usability. This is the kind of thing that was not always exactly the same for operational purposes as it is for protocol guys. And of course we'll be talking more about that later. In terms of other things that have popped up in BFD land outside of the working group, so IDR has actually had 2 proposals come up for doing BFD in a route server style environment, and one of them is the draft YMDK, the other one is the draft JDurand. They both cover similar pieces of functionality. The thing that's sort of interesting about this application is that this BFD is not necessarily protecting a protocol, but it's actually protecting the reachability to, in this case, a BGP next stop, which may not be the same as the endpoint for the protocol. One of the proposals contains a mechanism for actually reporting that up to other parts of the system. Interesting question for the working group, if you could take a look at this in your spare time, is do these types of signaling mechanisms actually have a broader place within BFD use for general applications, and should you consider trying to stand? I think the only other document that I have in my hand that I'm tracking right now is that the BFD proxy. I don't think we've heard from anybody about that recently. I think it's sort of going to continue to monitor this, but it's still the idea. So, first presentation is going to be for BFD Yang. Okay. And we've been requested for you to stand in the little box. We promise that a end will not fall on your head.
Thank you. My name is Prashad Raman. I'm going to be presenting the BFD Yang data model, which was put together by the design team. Yanshu unfortunately couldn't be here. We have Santosh who's here and Mahesh who's also part of the design team. I did publish a 01 this morning to correct the things which Benoit's tool had caught. There's still compile errors because we hadn't been using the IETF option in Pyang, so that's going to be Rev 02 at a certain point. Okay, so the goals we set out were to define a BFD data model that works for multiple vendors. We wanted to support all BFD session types in one data model, and also obviously this is Yang, so having the ability to support optional features was desired. Next one. Challenges. So a couple of things where we went around in circles and many Thursday evenings was, so initially we tried to have one key for all BFD OK sessions. And if there's any Yang experts here who can show us how to do that, that'd be great. But the way we went eventually, so because BFD is used to detect failures on different type of paths, whether single hop IP, multi-hop IP, MPLS, OK, etc., those different sessions have different keys. So after going around in circles for a long time, we eventually went in the direction of having a different list per session type. We'll be going over that a little bit later. So that took a fair amount of time. The second part was, if you look at existing BFD implementations, there's two main configuration models out there, rightly or wrongly. One is where the BFD timers is actually defined under the application which is making use of BFD to detect failures. So IGPs, BGP, okay, whatever, you can have the timers, and other implementations actually have the whole authentication parameters, etc., under the application. And then there's other implementations which have centralized BFD configuration. On top of that, something which we did not even address, but I see there seems to be closure in that direction now, there's the whole VRF-centric versus protocol-centric for routing protocols. We went in a protocol-centric direction. We might have to change direction to go towards VRF-centric. That's something which we'll have to discuss. Next slide, please. Okay, what's addressed in Rev 00 and 01? So we have single hop IP, we have multi-hop IP, we do have a model for configuration, we have an operational model, and we also have notifications. Next slide. What's not addressed? We don't have BFD for MPLS LSPs. We don't have BFD overlap. We don't have seamless BFD, no RPCs, and I don't know if there's anything else which we missed, but whatever is not in the previous slide, which should be there, is not there. Next slide. Okay, so centralized configuration. Right now, this is optional via the if feature. We have a session config container which has multiple lists of BFD session. There's one list per session type. And if needed in the future, if there's new session types, that container could be augmented if needed. For single hop, the key is interface and destination address. For multi-hop, the key is VRF, source address, and destination address. There's lots of common stuff between single hop and multi-hop, and we use groupings all over the place. Next one. So that one is contentious. As I mentioned at the last bullet on the slide, this is something which is outside of the scope of the BFD work group, which I've discussed with some people working on the IGP Yang models, and there doesn't seem to be any consensus on that. So that's maybe a question to you chairs on how to address that, whether, anyway, it's something we can talk about after. So what we've done groupings which BFD clients can use if desired. Right now we have two grouping. One is a base configuration grouping, which has the basic configuration, and the full grouping, which contains, demand mode, echo, authentication, okay, etc. Next slide. Operational model, we followed the same scheme as we did for configuration. We have a container where we have multiple lists, one list per session type. And again, the keys we use for single hop and multi-hop are the same as what we had in the configuration. We use lots of groupings. We have some counters there. So as Jeff was mentioning before, anybody who's got operational experience and can suggest new counters or getting rid of some, that would be welcome. Next slide. We have notifications. So notifications we have right now is when a BFD session changes state. We use groupings again to share data between the different session types. What's part notification? We've got local, remote discriminators, new state, etc. You can check the draft for more details. Next slide. So we need to get comments on Rev 00. We need to add what's not supported currently, MPLS, LAGOC and all that, seamless BFD. We need to tackle all the errors which came up over the weekend. And we need to go to discuss VRF-centric versus protocol-centric and eventual workgroup adoption. Questions?
Sorry, Sharon Devari. I have a question. You mentioned that the keys are very different in different applications, but isn't the your discriminator enough as a key?
Yeah, so we actually wasted a few meetings, we spent a few meetings discussing that. So if you look at so one thing is some implementations don't allow you to configure the discriminator. Some do and some don't. The second thing is RFC 5880 or anyway mentions that discriminator has to be unique per system. The definition of system, for distributed system, does that mean your whole router? Does it mean per line card? Okay, so yes, it is something we did discuss and we decided not to go that way for the reasons just mentioned.
So your discriminator right now is not a key, or is it an option?
It's not a key. It's not even part of the configuration. It's part of the operational model right now.
That's very interesting. It has never been like that. Yeah. Okay.
So if I could interject, one of the interesting things about that is I suspect there are good cases where we may want to put operational state in there to allow you to do queries based on discriminator. But again, the question then becomes in systems where you have a common management covering multiple separate components and your discriminator spaces are not guaranteed to be disjoint, how do you subkey that?
Greg Mirsky, Ericsson. So if discriminator is not a key, then how you provide their uniqueness in BFD over LSP. So basically that's what we discuss in clarification on 5884, whereas you can have multiple BFD sessions between ECMP of the same LSP.
So of the same FAC.
Huh?
Of the same FAC. Your basic thing is running on the same FAC. Okay.
So without discriminator, you cannot differentiate. You cannot support multiple sessions because by RFC, the discriminator is the only demultiplexer. Your addressing is just helping you, but you cannot use the address as a key.
Okay.
I think it's upside down.
So,
well, what you're asking is, are you suggesting that then to support what you just mentioned, the discriminator has to be configurable?
Discriminator is not configurable. If you look at procedure in 5884 in IPMTLS LSP, you must use LSP ping bootstrap, right? The way how this discriminator is populated in LSP ping is outside of the scope. You don't have to explicitly configure it. It comes from your system allocation, but it is the only demultiplexer. Your address or your LSP ID is not a demultiplexer.
But you cannot, if it's not part of the configuration, then it cannot be part of the configuration key, right?
But then you cannot configure multiple BFD sessions if it's not part of your...
Yes, I understood that from what you mentioned. What I'm saying is putting the discriminator in there doesn't seem to be
No,
the
but
solution.
okay, it's a it's
We do have a gap, yes.
Yeah, okay.
Yes.
Okay, we agree that there is a gap.
Yes. Mm.
Yeah, so just to clarify, sorry, Mahesh, Jetanandani. So, Greg, the issue was exactly that we realize that discriminator can be made unique. Let's say the problem. Well, considering the fact that we are talking about an operation, about a controller that's configuring on a system level, where you could have a conflict on the discriminator also. Anyway, the point is that even if it is made unique, let's go with that assumption, it is unique. It's an operational piece of information which cannot be used as a key
For config.
for config.
But then the model doesn't allow you to configure multiple sessions.
So in Yang, when you create a list and you have to give a key, the key has to be part of the configuration. It can't be part of operational data.
Okay, if this is a shortcoming of a limitation of the Yang, let's identify it as a limitation of the Yang, but we cannot accept substandard solution that doesn't allow you to support what RFC supports.
I don't think we can say it's a limitation of Yang yet. I think maybe we should have discussion. Well, okay, so just to add to what Mahesh said, we could use the discriminator as part of the key in the operational model for MPLS LSPs. That we could do. As to how would you configure, the question I have back is, in the case of MPLS LSPs and you have multiple paths, so you're saying you configure it, and then you would configure MPLS LSP on what? On an actual FEC? On an LSP? You would not configure it per path, right? You would configure it in one place and you would end up with multiple BFD sessions corresponding to that LSP, if my understanding is correct.
Well, actually, not necessarily. Personally, I do it differently, but we can discuss it offline.
Okay.
This is a Yang module. Please feel free to send a diff.
Since, so Mahesh, you mentioned that because that's a operational thing and you cannot model, can you not query it from the system to say, for this LSP or for this IP or this VRF, what is your discriminator?
But if you have, okay, so...
Because this is not really how it's implemented in any system. Everything is based on your discriminator.
Mahesh again. So I think the question that you have is so we're talking about generating a key for the list of BFD sessions, right? Which has nothing to do with what you put in the packet and send out.
Correct.
This is only for Yang or for people to query the session information.
So somehow, for example, I'm building a system or a chip, whatever. Although my chip does your discriminator, now I have my software, which is my API. It has to be able to translate between what you're saying to your
Yes.
discriminator.
Yes.
Okay.
Off the hook, no anvil, good?
No anvil? Please.
The relationship with this design team effort to Lime working group, can you talk a little bit about what
I
the plan is?
was hoping you guys would talk about that, but so we made the decision at the beginning to kind of ignore Lime until something more formal comes from Lime. And I haven't been following Lime closely. I don't know who has, but once something comes out which is firm, then we can start having discussions how to migrate to Lime if desired. Good?
So, who here is doing Yang work in other working groups? Okay, a couple. So I am going to again re-highlight the fact that we're trying to expose a portion of the BFD module that is allowed to be imported across modules. This is, as far as I know, a first thing in IETF right now for Yang modeling, and it's a practice that we want to get some feedback on early to see if it's a good idea, and if it's a good idea, We want to see if we can get it made a more pervasive thing.
Okay, thank you.
Thank you.
Good afternoon, everyone. This is Miguel Zhang from Huawei. In this draft, we specify the support of point-to multi-point BFD in trio data plane. Most of the issues we are trying to resolve in this draft are just the common issues for any type of P2MP BFD data plane. So that's why we want to present here to receive your comments. Next slide. First, let's brief the session model of point-to multi-point BFD. In P2MP BFD, the head will have a multi-point head session that is bound to a multi-point path. And the tail will has a multi-point tail session associated with this multi-point path. If the head wants to track the active status of the tail, it needs to set up the multi-point client session per tail that it cares about. All these multi-point client sessions for tails on a particular multi-point path are grouped with the multiple head session. Next slide. In the trio campus, trio switches can calculate multiple trees. If these trees are calculated in a way that they are disjoint, then trio switches can perform some kind of protection. The head can perform a global protection by switching from one tree to another if a failure is detected. In order to detect this failure, the P2MP BFD is needed. Next slide. BFD control packets are forwarded in average channel. The ideal average channel is to forward control packets as payload of trio data packets. The receiver abridges can identify these channel messages from its ether type or the MAC address. And these receiver abridges will absorb these messages and does not deliver them to the end station. Next slide. Actually, point-to-point BFD has already been supported in Trio. It has been published as an RFC. In this RFC, 2 code points were allocated to P2P BFD. One is for P2MP BFD control packets, and the other is for BFD echo packets. In this RFC, it defines that if the M bit of the packet is set to 1, it means that this packet is a multicast packet. This packet should be discarded. However, the point-to multi-point control packets need to be sent as multicast packets. So when these packets are forwarded in this number 2 average channel, it will be discarded. In order to resolve this conflict, we need to define a new code point for point-to multi-point BFD. But for the unicast BFD control packets sent from the tail to the head, we can reuse the number 2 average channel. Next slide. By announcing this new average channel code point, averages are actually announcing their capability to do P2MP BFD. This new this new code point is carried in the average channel protocol subtier way in LSPs. Next slide. The last thing is about demultiplexing. In order to differentiate the BFD sessions, the head will set the discriminator, and the tail will use this value to do demultiplexing. In addition to this value, the tail will also use the ingress nickname and the VLAN value in the packet to do demultiplexing. So the tail will use my discriminator, ingress nickname, and VLAN for demultiplexing. Next slide. Okay, please read the draft and provide your comment. Next step, we want to request adoption in the trio working group. Thank you.
Any questions? So it's worth stating that this document does require the active tail work that Santosh had spent out. So the original intention for that document, as part of splitting it out, had been to move it towards experimental or informational. And since I believe you are trying to get your document within TRIL be a proposed standard, that means that we will have to also continue our work for active tail for BFD as well.
Yes.
My request to you in the TRIL working group is, since you are the first user that is dependent, please help that active.
Okay. Okay. Thanks for the suggestion. Thank you.
Nobu Akia from Big Switch Networks. So, presenting the seamless BFD alert discriminator. This is sort of the last piece of the puzzle for me as the SBFD core functionality. So why is this needed? Well, we do have the extensions to advertise the seamless BFD discriminators through IGPs. There's also, I saw that BGPLS extensions from some of the members from this room. So we have that already, but for other uses, things like InterOS or things like there is no control plane running that can advertise the discriminators, what do we do? Well, wouldn't it be nice to have a common way of doing this within the BFD layer instead of trying to extend all the protocols that's required to do it or whatnot? So this is the primary intent of the seamless BFD discriminator, or seamless BFD alert discriminator, is to do the discovery of the remote discriminator at the BFD layer. And then there's a secondary purpose which allows for future extensions if required. So how does this work? It's fairly simple. The key is what's sort of in red font, which is on the left-hand side. When the SBFD session is started up, you actually set the your discriminator to 0, which is the alert discriminator. And that's sent across to the targets, and target sees this. It says, this is your discriminator 0, it's a special discriminator. So he's asking for what my discriminator is, my seamless BFD discriminator is. So I'll populate my seamless BFD discriminator in the my discriminator field and send the response back. So now, step 3, the initiating node actually finds out the target's seamless BFD discriminator. Therefore, step 4, you can actually go to the normal operation of doing the ping pong operations, right? Because you find out what the remote discriminator is. So the key thing here is the usage of 0 as your discriminator initially, which is the special one. Just discover the real discriminator on the other side.
Chatham Diwali. But this is how it works. This is how the BFT was designed. What's new?
This is how BFT
Works.
is already designed,
Yes.
and seamless BFT is sort of different
Oh.
variants of BFTs, and this is not there yet. But it's not much
You are
different
saying
from
use the same
BFT.
thing. You are saying use the same thing for seamless BFT.
Pretty much.
Hi, Greg Mirsky, Ericsson. What Sharon points out, and I think that's a valid question, is that we are coming to the same 5880 from another side, because their advantage of SBFD was that discriminator exchange process taking out, and so you do it orthogonally, and everything else works the same. So now you find that there is a need to do dynamic protocol discriminator discovery, and it brings back the whole BFD process. So might be then it would be not SBFD, but it would be just BFD. Because we're kind of going circle. So we started from 5880, we took out discriminator negotiation process, we got to SBFD. Now we're adding this alert functionality to learn dynamically remote discriminator, and we're coming to 5880.
I think that's a fair comment.
Now just think about it.
I did for a few seconds. But it's actually valid that, but let's say we didn't do this. We didn't do the alert discriminator. Now we want to use SBFT for different places like VCCV or DS Lights and all this stuff. Now you have to extend every protocol to be able to exchange the seamless BFT discriminators ahead of time. That's one way of going about it. The other way, as sort of if you want to do the protocol extensions, great, let's do that. But for other smaller cases, if those people don't want to, but they're okay with some smaller initial delays for the startup, they can use this.
So if I could throw in a comment, the discriminator discovery, certainly that is one thing that we had hopefully gotten away of, but the big thing, to me, the big thing that SBFD was always useful for was the fact that it's really a stateless BFD. You're not actually having to set up sessions, you're not having to maintain things, you just have the little, ping pong type behavior going on. I think that's still really the core benefit of this functionality. The fact that we have to have a bootstrapping mechanism does make it one step a little more painful. This is one way to do it. If you want to do it in the protocol, he's saying that makes sense too.
Yeah, I think that if really we want to maintain, and I agree with Jeff, if we really want to maintain stateless on the reflector, then rather let's go for their extension on outside of the protocol discriminator advertisement and distribution, rather than put it into the protocol, because in my view it creates some state on the reflector.
So how is it so much state and...
Because what happens if you want to change this discriminator on the reflector without telling everybody you told? Do you need to tell them you're changing your discriminator? In BFD there is a process of what you do. You can go in admin down, you can change, you can come back. So there is a whole machinery that supports it. Okay, so I'm concerned that by doing this first step, we'll end up where the 5880 already is.
Well, I do want to say that if the working group feels that protocol extensions to advertise discriminator is the right way to go, then I'm okay with that. It's just additional work we have to do for every protocol to be able to do that. But if this is a consensus, then that's the direction we'll go.
So we have a comment from Jabber. This is from Pingada Govindam. How do we extend this mechanism if there are more than one target identifiers configured on a node? In other words, does using the alert discriminator limit the number of target identifiers to be 1?
So if you want to have more than one SBFD discriminators maintained on the reflector side and use this mechanism, you sort of have to do the demux based on the incoming packets, whether that's, it has a label or it has some IP fields, the destination and whatnot. You have to do some groupings based on these type of packets I'm receiving will map to this discriminator, the other ones will map to those discriminators. So there is a way of doing the demux that way.
Santosh from Juniper. I had the same question. Like in case of MPLS, the IP address that you receive is 127. So if you, in SBFT based document, we are saying that the UR discriminator is one of the things where will be used to say that this is targeted to you, right? And here, since it is 0, there is no way you can say unless you go into depth of the packet saying that, or maybe the labels and other stuff. Maybe that needs to be cleared here, saying that we need to demux based on that.
Okay. Chair? Is it possible to get a sort of feel of the room?
So I think I'm hearing at least 2 questions here. One question is, should we even be doing this? And the second question is, even if we want to do this, there are some corner cases that are being pointed out that make this a little tricky. And we can sort of so we get a sense from the room for whether you think this should be done within SBFD as specified as an option, keeping in mind that if you want to do it inside of a protocol, it's still a fine thing. So hands or hum, whatever you're comfortable with. I thought it was. Who is happy seeing the SBFD mechanism as specified? Yes, like this. A couple? And who would prefer to see it exclusively within a protocol distribution mechanism? A few more. Okay. And Davengata is also humming a little.
For the protocol?
Well, that's the problem with the remote stuff is I wasn't paying attention when it showed up.
Okay, thanks. I think there's one more slide after this, maybe. Let me quickly go over this. This is just pretty much repeat of what I said on the first bullet, 0 as the alert discriminator. The secondary thing is that it does provide extra capabilities for future extensions if you want to, by being able to encode a specific diag field which has specific instructions defined for it. And next slide, please. I think this was it. So that would be it. So I'm going to try to grab some of you after this session to see if I can talk to you to get more idea of what we should do, and maybe I'll relay that to the list afterwards and see if we can come to consensus to how to move forward. Thanks.
So our next presentation is going to be SBFD for ECCV storage.
So I'm kind of just the guest presenter here. Okay, so next slide, please. So this is about a piece of work to, a slightly larger piece of work to get SBFD to work in a pseudowire context. And we need it to work for both L2TP pseudowires and for MPLS, or pseudowires running over MPLS. At the moment, the work is considering just the static MPLS case, and the LDP signaling will be in a future version of the documents. Plan is to reuse the encapsulations and protocol procedures of RFC 5885. That's the VCCV specification, and define the additional mechanisms that we need to support SBFD. We'll need some new CV types. The SBFD echo mode is not in scope. And SBFD will be used to provide fault detection only. The fault detection status signaling, however, is out of scope. Next slide, please. So we have a few options, and we're looking for feedback on some of these. So we have a number of ways of doing the SBFD discriminator advertisement. One is to simply use provisioning, and for a provisioned pseudowire, that may well be the right thing to do. Another is to use the alert discriminator that we just spoke about. For L2TP, there is a draft GP, L2TP extensions, SBFD discriminator, which describes how to do the advertisement within the L2TP protocol. If you recall, L2TP has got its own private signaling protocol. Then we need to think about the encapsulations. Probably the simplest one is the IP UDP based encapsulation. You'll recall that BFD can go natively, or it can go inside an IP UDP encapsulation within the OAM channel. Well, when we're going inside the IP UDP case, then we will just use the existing SBFD async UDP port. So that's kind of a fairly simple transplant. In the case of L2SS, which is the signaling protocol for L2TP, and actually, is it a signaling protocol or is it the header? I can't remember. And the pseudowire ACH-based encapsulation, we will not need new IANA types, and we'll have to write that up and specify it. Next, please. So the initiator options. We need two CV types requested for SBFD operation. Option one is to use two reserved bits of the existing parameter defined in RFC 5885. And option two is to use some bits from the VCCV extended CV parameter TLV, which is defined in RFC 7189. We will reuse the reflector operation, or we propose to reuse the reflector operation from the seamless BFD base specification. And then we need to consider the capability selector. And I must say I've had some discussions with the authors of this draft from a perspective of someone with experience in PALs. What we need to figure out what the order of preference is between SBFD and BFD. We need to know whether we can make them independent, and do we operate in a no order of preference mode. I'm afraid I personally think that that won't work very well, because you really want two systems to come up, and you can't negotiate unless you have a tiebreaker of some sort, and that's a lesson that we learned in PWE3. So feedback on that, and of course I may be wrong in that, but feedback on that is particularly welcome. Next slide, please. So we'd really like the working group to read this and give us some feedback. There'll be some more discussions in the PAL working group where this is also going to be presented. We need to close off a bunch of options and items, so help and steerage will be good, and a new version will be submitted, and we'll ask for working, or the authors will ask for working group adoption. Greg.
Yes, hi, Greg Mirsky, Ericsson. My understanding that motivation for SBFD, one of it was that BFD echo cannot be used in multi-hop environment.
Can it? Why can't it?
This is packable. It technically could in some restricted circumstances, but
well, it's because you're sending BFD packet with a self-addressed, so it's only for the single hop.
So in environments where you're willing to accept the FT echo coming in a interface that is not the one you're originating it from,
No,
that's permissible?
No, but in multi-hop environment, if you send it more than one hop, it will come back to you. It would not reach your destination. Okay, so that was one of the reasons to have SBFD to work as extension to the multi-hop case of BFD. For the pseudo-wire, I think that it's not a requirement because Echo BFD can be used over pseudo-wire. So then, hence my question: why not to adopt Echo BFD to the pseudo-wire rather than adopt SBFD?
Sorry, say again? So echo mode would require echoing in the data plane, wouldn't it? And doesn't that mean a potential change to the data plane for a lot of existing implementations as opposed to a small, mainly control plane modification?
Why would it be a change in the data plane?
Well, how would I get, for example,
Oh.
the focus of this is pseudo-wire. Pseudo-wire doesn't have the concept of a multi-hop pseudo-wire going back. In fact, I don't think it can do it.
No, but again, the pseudo-wire is if the pseudo-wire, if a single hop pseudo-wire, it's a single hop IP-wise, right?
So a single hop pseudo-wire is a single hop in the pseudo-wire plane, but not in the LSP plane.
Right, but in LSP plane, we are not terminating the LSP until we're terminating it. So
Correct.
That's why IP header would not be exposed.
So two things. One is that if you have the IP destination address as self, and there's a breakage in the pseudo-wire that IP header gets exposed somewhere in the transits, you still get the packet to come back, which is false. It might. It's because well, if a node just pops the VC label, right?
Oh.
And you have your IP header exposed, which means the destination of IP header is the sender.
It will be dropped because it doesn't have your discriminator.
If you're sending an echo packet,
it does have the same discriminator.
But the echo is basically routed, right?
Yeah.
Until it reaches the destination of the packets.
No. Echo BFD request does have discriminator. So if you end up on some transit node, which
The discriminator is your own discriminator of the packet you're going to get back yourself, isn't it?
No. Again, okay. It does have discriminator of your peer. Your discriminator is a discriminator of your destination.
We're talking about echo packets.
Yeah.
Echo packets is, the content is by RFC 5880. It's not defined, right?
No. It's BFD control. It doesn't define the payload. It can be variable payload.
Correct. Correct.
But it uses the same UDP port as a BFD.
It uses +1, 3785.
Okay.
There's no information in the payload to tell you what section you're expecting to track with that. And you're smart enough to put in your payload pretty well, but there's nothing that necessarily
Okay, I think I need to refresh my memory then.
Okay.
So
Feedback welcome.
So the question I have used here to the authors, do you expect this to be adopted in PALs? Obviously, sort of for us to continue working with that. Potentially some clarifications in the procedure, and an awful lot of work that needs to happen in that PALs.
So we need to, there are two drafts. We need to figure out which is the right home for each draft on a sort of per draft basis, as it were. I imagine that anything to do with 5585 is most definitely PAL's work.
Sorry, that question. Sharon, the very broad one. One question you mentioned about VCCV type. Are you going to define new VCCV type or new ACH channel type?
Well, if it's going natively,
Natively.
I think it has to go on a new ACH type.
ACH channel type.
Right.
But then
However,
yeah.
there is a question of what you do during bring up,
Yeah.
where the two ends in 5585 agree which of the various OAM protocols they're going to use. And the question is, if one side can support, if both sides can support both, which of old-fashioned BFD, SBFD, or both do you support? Because you might want to concurrently support both of them for different features. And my concern as PAL's chair is that leaving this as an open question probably doesn't work, because we need to be able to bring two pieces of equipment up and they have to do exactly the same thing each time they come up, and what the operator expected them to do.
And then the second question I had, so the SBFD, I don't know, whether, does it run on any VCCV channel type, 1, 2, 3, 4, all 4 of them?
I'm not sure. I hadn't thought about that.
Hopefully it's only 4.
Yeah. I would, sorry, what? Hopefully it's... Yeah.
There is a further comment from whether it's going to be the VCCV type versus a new channel type, and Prasad suggests that it's going to be both.
Say that to me again?
So when the question was, are you going to define a new VCCV type or a new channel type?
Or both?
His
I
answer
think
is
it has to be both.
that was his comment. So blue sheet check, if you have not signed it, and this room is feeling a little bit small to you, it's your own fault. While we're doing blue sheet check, our next presentation is on BFD authentication.
All right, hi everyone. Pretty simple draft here. Can we move to the first slide? The problem with authentication today is, well, you have to authenticate every single frame at a very fast rate that can be very computationally intensive, resulting generally either in limits of scale and stability for the sessions, or requiring you to use more expensive equipment to implement authenticated BFD in hardware. An additional problem, soon MD5 and SHA-1 will not be adequately secure. MD5 is already not accepted for JITC certification. SHA-1 is soon to follow in the next couple of years. So we are going to have to start using more complicated algorithms to authenticate BFD and other protocols. So the solution, can we move to the next slide? One solution, the one that we are presenting, is to authenticate only a small number of BFD frames. Authenticate only the frames that cause a state change in BFD. So that would be frames with state down, admin down, init, the PF sequence, and the first few up frames to change the state from init to up. That's all fine and good. That does reduce a lot of cryptographic pressure on the system, but that does leave the system open to man-in-the-middle attacks with the session up. Now, one proposed solution is to send periodic up frames with authentication fields, maybe once every 10 seconds, or faster if the threat of man-in-the-middle attack is severe enough. Next slide, please. Now, what are the benefits of using this mechanism? We authenticate a significantly smaller number of BFD frames, so that's great. We can use stronger algorithms since now we have fewer computations to take care of. And we can do all of this without significantly affecting the security of the BFD system. When the system is in up state, when we are exchanging packets at a fast frequency, there aren't that many attacks that are going to affect the system without changing the state. A man-in-the-middle attack can still hit this system if the attacker is trying to keep the session up, and that's the only scenario. If there is no break in the network link, and if an attacker is trying to keep the system up, fair, no harm done. If the system does go down, there will be frames sent out with authentication set. There's a comment?
Yeah, Sharon. So I think you don't need this because in non-meticulous authentication, you only compute this once. You don't need to compute it for every packet. So just use non-meticulous for this, and then whenever you need this state change, just change the sequence number.
Agreed. That's one very good solution. The problem, however, is that in non-meticulous as well, while you compute it once, you still have to check that field in every frame. You don't have to do a cryptographic check. There is still a mem compare.
Yeah, but checking that is easy. It's not very difficult to check.
Agreed. It's easy. But you can avoid even that.
Greg Mirsky, Ericsson. So their proposal here removes the burden on a stable case when everything is fine.
Correct.
Then, when there is a state change being reported, authentication kicks in. So to realize that there is a state change will take longer to their system than the recipient.
Agreed.
So does that defeat the whole purpose? Because
from a non-authenticated system, yes, there is more computation here. From an authenticated system, there is no difference.
Yes.
Because there you would have to do it anyways.
In my view, that usually it's better to make your worst case scenario your normal case scenario.
Agreed.
So then why to go through all incremental improvements when you still will have your worst case scenario, because the whole goal of BFD is to detect the failure.
Agreed. So you bring up a good point about being efficient in the worst case scenario. Now, how do we define the worst case scenario? For certain systems, keeping a large number of sessions up at a high frequency is a bad case. The ability for the system to scale with relatively cheaper hardware or relatively constrained processing resources is a fairly problematic
from my
solution.
Experience, if the system cannot, or if the system hardly can sustain authenticated, non-authenticated BFD session, but authentication will kick in when the failure detected, then none of these state changes will be detected.
That is correct.
Okay, so basically we are scaling for the good weather, but will fail when it starts raining.
Agreed. Just a point of clarification, the comparison that we are making here is against a fully authenticated system and not a system without any authentication.
So, Santosh from Juniper. So you raised the point, saying that you want to exchange authentication for every 10 seconds or so periodically, right?
Right.
So we are already in the aggressive interval when we are in upstate, and some implementation might not have this authentication. You can't even have an authentication when you are in aggressive interval, for example, 100 millisecond or so. So in those cases, since there is no negotiation, how do you ensure that, yes, we can do this or we can't do this?
That's a great point. That was one of the open issues that's listed in one of the slides. We still haven't completely ratified how we want to negotiate this optimized BFD authentication capability. And we'd love to get more feedback from the forum. So moving on to the next slide, we are going to go over some of the open issues that we have. This is still a very early revision of the draft, so plenty of open issues here. As I had previously mentioned, there is still a small window for man-in-the-middle attacks, even with the authentication of up frames every 10 seconds or something along that line. That up-frame authentication can be made more frequent to minimize that window. And we'd probably want to leave that up to the operator to decide their tolerance for such attacks. Next slide, please. This requires a change in BFD frame handling. As implementers, we all hate changing anything that has to do with the BFD logic. It's already very highly strung. For software-only BFD implementations, it's a fairly straightforward change. Not too much there. You see an authentication bit set in the frame, you authenticate that one. More complicated when you have to change the ASIC logic. And it's relatively simple in hybrid implementations where only the frame transmission and receive is hardware accelerated.
Sharon, just to clarify, you are not proposing any new standard because you already can do what you want to do.
Absolutely.
There's one bit in the BFD header that says this is authenticated.
Yes, ideally you'd want to use existing BFD frame types to do this.
It's only information.
Except until we ratify how we want to do the capabilities negotiation. If that requires a change in the way BFD frames are generated, then yes. Otherwise, no. Yeah, I agree.
To jump in, there is some cautionary text in 5880 that says that you should really only transition in and out of authentication exactly once. So the protocol does not forbid you from doing it, because we have sort of the typical Dave Ward, Dave Katz weasel words about it. Clarifying the actual procedures when we want to allow this sort of thing, I think is probably going to be in scope for this document. It's probably the more contentious thing.
Right. Next slide. Yeah, we've already discussed the need to negotiate the capability between peers for this capability. So we can just move on to the next slide. The system is still, like all authentication methods, open to denial of service attacks. We can try to rate limit, although that's not really a solution. So we need to have further discussion on how to prevent denial of service attacks. And next slide. This is again the question that Greg brought up. When many sessions change state from up to down, the authentication system load is going to be fairly large. But again, it's going to be no larger than what you'd expect in a fully authenticated system. Session establishment, however, can be rate limited to reduce that pressure.
Mahesh Chetan, Sienna. So I think talking about session change and that causing a load, as we clearly pointed out, it doesn't add anything more than what today's fully authenticated BFD sessions would require. I think one of the pieces of information that we realized was that when you don't authenticate every frame, you're not queuing as many frames also for analysis. So that itself is a change from authenticating every frame. So that's something to keep in mind.
Thanks.
Novo. So this also applies when there's a PN poll and final bits exchanges. Is that
Right,
correct?
right.
Okay, not just state changes.
Not just state changes, poll and finalism. Anything that has an effect on the operational data that BFD holds, operational state. And that would include the negotiated intervals. Next slide. Oh,
Also, something else I wanted to point out also is, I think from a, sorry, Mahesh Yatandani again. So the constant frames, the frames that we're sending at the required interval are also time sensitive, and doing auth on those tends to add more sensitivity to the hardware, whereas state change frames are not as time sensitive. And therefore, yes, the authentication will take a little longer, but that may not necessarily change the ultimate state of the BFT. Whereas authenticating every frame and being able to support that many frames does cause problems in the BFT sessions.
Sharon Devari. Actually, we have implemented this BFT in software, and doing a non-meticulous and doing no authentication is completely equal. We can run exactly the same number of BFT frames per second, whether it's non-authenticated or non-meticulous authenticated.
All right.
Because you just compare two numbers. It's nothing.
All right.
It's just a hash function, right? Just a digest.
Agreed. And next slide. I think we've already discussed this one. And that's it. Any questions, comments? So this is a very early draft, as I had mentioned, so we are not proposing what the future of this draft should be. We just wanted to open up a conversation on how to optimize authentication for BFD so that it becomes a little more practical in highly scaled systems.
So, Mr. Jeff, I wanted to remind the working group of some of our past conversations about authentication. One of the problems that we've always had with authentication aside from people wanting to turn it on, because sometimes people are not comfortable deploying authentication in their network, especially if they don't have good key rollover mechanisms, is that it reduces the number of sessions in their network. And if you're somebody that's extremely security paranoid, the mechanisms we have today, the SHA-1 and MD5, are at this point being suggested by the security people not being strong enough. And one of the bits of work that we got courtesy of CARP, and we have two open drafts which have not made good progress on, have been towards introducing SHA-2 type authentication. And the single biggest motivator to not do any of that to date has been that the cost of the SHA-2 is so much worse compared to SHA-1 that it is undeployable even in pretty aggressive platforms. One of the interesting things about the proposal is that if you are security conscious about such things, this may actually make it more quickly deployable, and it may provide a little less excuse for people to do sessions that are unauthenticated. One of the things I think would be sort of interesting is just looking at this procedure, even if it's something like clarifying what procedure should be for a non-meticulous mode, to try to get authentication in better deployment processes. So for the procedural type changes, questions, so you're at this point just shopping the draft around, seeing what the intention is. Are you looking for adoption anytime soon?
In the next version, we would be.
And just as a quick poll of the room, who is interested in seeing this work be adopted in the group and potentially advancing? Are willing to help them work on this?
All right. Thanks, everyone.
Next draft is on BFD stability use cases.
Okay, good afternoon, everyone. I'm Santosh. I'm presenting the BFD stability use cases. Couple of IETF. I mean, in the last IETF, Ashish has presented the BFD stability. We did miss the use cases in the draft, initial version of the draft, and over the working group. There was a strong request for the use cases for this draft, and today I'll be presenting that. Okay, the objective of this draft, I wanted to make it very clear that BFD stability will be used to detect the BFD session flap and the reason why it flapped. That is one of our objective, and the second objective is to to detect any drop or delays in the BFD packet itself, to know if there is if it's going to lead to any BFD session flaps. So these are the two objectives of this BFD stability draft. We are not attempting to measure any traffic or traffic loss or delay loss on the link or the tunnel. So, and also BFD stability solutions that we have proposed is not even equipped to replace the CFM, LMDM or any other loss delay measurement tools that are out there in the market today. So it's mainly our objective is to detect the BFD session flapping or maybe preventing BFD session flapping, right? So, next thing. So the use cases, when we talk about the use cases, right, there are two use cases like I said before. One is that BFD session flap notification. Why did it flap? And the second one is to detect if there is any drops or delay in the BFD packets itself. So there could be two scenarios in which this could be happening. One is that you have an LD link, but you have a faulty BFD path within your system, where the BFD might be taking a queue which is getting dropped. You have a faulty queue there, or maybe that is getting delayed, because of which your BFD sessions might get flapped or BFD packets are getting dropped. That is one of the scenario, and the second scenario is that you have a faulty link. Where BFD is one of the victim, where it's getting dropped because along with the traffic, right? So these are the two scenarios in which we would like to see how this would help us. In the coming slides, I'll be explaining that. So in case of, like I explained, you could have an healthy link, but you have a faulty BFD path. So we might argue saying that in that case you might want to run a CFM or any other LMDM and know why what is happening in the system. But it could be possible that CFM and any other OEM might be taking a different queue path altogether within the system, and BFD might be taking something else. So in this case, it is just BFD that is getting affected and no other OEM that will detect any issues with the BFD, right? So that is one of the scenario. The second scenario is that the link itself is faulty, and you might want to detect if there is no CFM or LMDM or any other link loss measurement already running, and BFD is indicating that there is a loss. You might want to use that as a trigger and run the heavyweight protocols to detect loss or delay. Right. So an interesting use case for this is BFD drops and delay detection. In case of you have an LD link, but BFD is faulty. So it could be possible that it is giving you a false negative cases, which could lead to catastrophic situations, or maybe it will force you to use the suboptimal paths. Few of the suboptimal path scenarios I have highlighted. For example, it could be single op LFA with single op LFA with LFA enabled, or maybe micro BFD load balancing and MPLS TP with primary and protected LSPs. So in this case, what could happen is if BFD is flapping, or maybe BFD packets is getting dropped or delayed, if operator checks the monitors the health of the BFD session, then he could notice that, okay, BFD is flapping. This could lead, BFD packets are getting dropped or delayed. This could lead to potential flap, which could internally trigger the FRR, or maybe a load balancing and MPLS TP, which could be avoided by looking at the BFD statistics, which BFD is already reporting, and then take an action based on that. He might want to run CFM, LMDM, or whatever other heavyweight protocols, and to figure out where is the problem. If it is local to the system, he might want to just disable the BFD session, so that you want to avoid all the FRR and other convergence stuffs that's going to happen, right? So if you have an faulty link itself, So and if you're running BFD and and you are not running any other heavyweight protocols like link and loss measurement protocols, then you might want to use this BFD reporting the loss as a trigger, one of the trigger, and then you might want to run CFM or LMDM and to figure out what really is happening, right? So this is one of these are the two use cases that we have come up with. Next slide. So if BFD session flaps, then we also want to indicate BFD session flap reason to the application, or we want to log this saying that the reason for the flap is either the drop or the delay or loss or the delay. Right. It is important in kind of if you are not already running all these heavyweight protocols, you might want to run it, and also it helps all the implementers in case of why the BFD session flapped, because we spend nights together to figure out what happened really is it within the system or is it outside the system. We have no clue, at least with all the aggressive BFD sessions that are running. So to detect the flap, you might want to keep a minimum local state in the system post flap so that you know the reason why it flapped. Otherwise, you always think that it flapped because of BFD packet getting dropped. It might not be the reason, because if BFD packet is getting delayed, you might want to receive it and convey the same to the upper layer. So there were a few questions in the working group that were already asked. We tried to answer over the mailing list. I'm trying to highlight few of the important questions that were asked and trying to answer them here. So the first question, like, what do you do when you detect that there is a loss? Like I said in the previous example, like, the notification can be used to trigger any heavyweight protocols, and also to help the system itself to know where exactly is the problem, right? And the second question that was asked is like, how do you detect if the BFT session went down? Because most of the implementation is such a way that, if the BFT session goes from up to down, you just remove the state, and there is no way you detect what is the reason. Like I mentioned in the previous slide, we need to maintain a minimum state so that we actually detect the accurate reason of BFT session flapping. Right? And there was one more interesting question asking that is it an OEM for an OEM, because we were saying that trigger an heavyweight protocol based on the BFT trigger, but it's not really OEM for OEM. It is just that we want to debug the issue faster, plus help avoid false negatives. These are the main objectives, but it could be used as a trigger for any other protocol. So that's the use case from my side. From our side, any questions? Thank you. Yeah.
So you're proposing a new authentication type for this?
Yes, that's right.
Basically, just to use the sequence number.
Right. Just use the sequence number, yes. But recently, while talking to Manav, he also suggested adding the bytes after BFDs.
Yeah, that will be better. The TLVs are not good for this.
Yeah. So the proposal, this is an initial proposal from our side. Maybe we can discuss over the mail and figure out what is the better solution for this.
So the addition is a timestamp in the new authentication, right?
Sorry, Nobo, can you?
Nobo. The addition to the draft is the sequence number. Sorry, sequence number.
Yeah, right. I mean, that is our initial proposal. Like
Okay.
I said, we might want to consider any other better ideas out here.
So if the sequence number is the addition, it doesn't really help you with the delay detection, right?
Delay, it does, right? Sequence number, if we have, if the BFT session, I mean, we want to see receive a BFT packet and see that it is the continuation of this, then yes, it is a delay. Or if it has reset, then it is like the complete new session that is forming up. That means there was a drop.
It can help you with the drop.
Yeah.
And if the two packets come in with the reverse sequence, that's if it's
When
delayed
wrap
that
around, right?
bad,
Yeah, that is.
then it can help you with delay. But in normal sequences, addition of the sequence alone is not going to help you with the delay. Right?
Yes, like I think there were discussions around that as well internally, not on the working list, and maybe I'll post that whatever the discussions that happened on the mailing list.
Greg Mirsky, Ericsson. I think it's very interesting and valuable input based on your experience in deploying the BFD. What I wonder is that, so currently it's targeted as a standard strat. Would you consider taking it experimental?
Okay.
Don't need to answer right now, just think about it.
Sure, sure.
Great. So I think it's sort of well known that you were probably the one that most vehemently objected to at least the original proposal, just simply based on the fact that it was looking a little bit too much like CFM. This is sort of the stripped down version of it. Most people are detecting stuff strictly within BFD scope. I guess my question to you would be, what would it take you to move from the idea of this being experimental over to something that should be standards?
Okay, the backward compatibility.
Do you have any thoughts on that?
I see some problems with the hardware supported implementations.
So backward compatibility, when you say like, setting the A bit and adding extra TLVs, okay.
Mahesh Chetanandani, Sienna. So the 00 draft actually proposed that we not add the times, or maybe we did. But one of the proposals that we did play around with was to say, if adding the TLV was an issue for existing implementations, that we could just do the drop measurement using the existing structure of BFD. So the only change would be the auth bit would, had a no auth option, meaning so that doesn't change the format of BFD, but still at least allows you to detect loss.
That's something that we can discuss. Again, the rule that practice, well, at least in my experience, most by MPLS and PRS-related groups is the backward compatibility, because you already have a lot of installed base, and you already have a lot of BFD implementations that are hardware supported. So changing format, I don't know many that do use any payload on a BFD control packet.
So that's a good input of backward compatibility. We will work on that and update the draft as well.
Rashad from Cisco. Could we use this for echo? So, I mean, I know echo is not...
Echo?
Sure.
Echo by itself doesn't have any echo, packet format, right? So we could just use the echo, but the problem with echo is that it is just a single operate today. You can't use it anywhere else, not even on MPLS. So,
Mahesh Chetanandani. So just a clarification, when we talked about backward compatibility, now if we are adding a new TLV, assuming that this is a new TLV, isn't that, just a, it should be, right?
any more questions? Okay, thank you very much.
Greg, you're up. We're actually being efficient.
So I didn't waste much time in comments?
No.
Yeah.
Okay, now I change my head and present, so send your comments here. This is an update on the work that we're doing, and this work is anchored at MPLS working group, but since it's on the BFD, so thus we're keeping BFD working group up to date on our changes. We had two documents that try to solve very similar scenario, And after a meeting in Honolulu, authors of two drafts got together, discussed it, and agreed to continue working on one document. So thus, now we welcome Mark Chen and to our working group, and we'll continue progressing this document together. So there were two more changes, and we identify a new error record code to be sent if suggested reverse path cannot be found and cannot be used. So then return code can be used. And there are two scenarios. In one scenario, because we consider this path that being suggested in a return path TLV as recommended, is not mandatory, so that target system may decide to use IP plane for reverse BFD to act in accordance with the 5884. In that case, and again, 5884 says that recipient of echo request may send echo reply back. So if that's the case, then sending echo reply back, it can use new error code to report that it didn't use the requested return path. But if the system decides not to establish a return path over BFD, that our document states that it must to send echo reply back and must use this new error code to indicate the error. And then we made some editorial changes, changed the terminology, and that's all changes. So we'll be presenting this at MPLS working group, and we're planning to ask the working group to consider adoption of this document.
So this is the working group's opportunity to play Greg Mirsky and ask him hard questions. Well, thank you for the update.
Okay, welcome, thank you.
So we asked originally for an hour-and-a-half session. We have actually hit an hour and a half out of a 2-hour session. This means we have time for open mic, commentary, impromptu design team stuff in case the BFD Yang group would like to get people together and actually have some interactive talk about things. Otherwise, you are free to go until you can get your piece. Thank you, and we'll see you soon. Oh, Yoa.
So, if I can remember the name of the draft, I'm going to ask what status of the draft, and that's, Nobu and I have been discussing this draft a little bit. It's draft, draft BFD, IETF, MPLS, sorry, the IP one that actually do both IPv4, IPv6, and MPLS. Where is it?
Self-ping draft? You're talking about Ron Bonica's self-ping draft.
Yeah, the one you sent to me.
Mm-hmm.
No, it's not self-ping, it's the SPFD draft in this working group.
Oh, yes.
So what is the status of that? Are
Okay.
you ready to progress it soon, or is it dormant, or what happens?
So the seamless BFD, there is the first one we want to progress is the use case draft, and it's actually Greg has a pen to make some final updates, and then it will be able to progress to RFC, and then that will be followed by the base draft, seamless BFD, and then the IP data plane draft, and which will cover the MPLS aspect as well.
So what do you have in? Will this happen before Prague or somewhere near Yokohama or what?
Use case probably I'll have
in 2 weeks. So that will mean we can probably hit, are we going to push base and IP draft together? Okay, so we'll try to progress fast, but we can't promise that it will be before Prague.
Okay, but it's sometime after Prague. And
Yes.
Okay.
Yes.